Hi guys, it's Professor V. Welcome to another Teach to Code. So today I figured we're going to do some pre-algebra. It's one of the big things I used to teach back in the day, so I'm just trying to brainstorm what kind of program to build. If any of you guys have any ideas, please put them in the comments below. So let's go ahead and get started. So I'm going to start a new project, a Java application. I'm going to go ahead and name this Pre-Algebra Test. And I'm going to go ahead and build the package. So the test class is going to be the one that has the main method within it. So within the Pre-Algebra package, I'm going to go ahead and create a new Java class. And I'm going to go ahead and name this just Pre-Algebra. Okay. So we're going to do quite a few things, and I think this is going to be my series for a while until somebody suggests something or they need another problem solved. So one of the big ones we used to do was Fahrenheit to Celsius and Celsius to Fahrenheit. So let's go ahead and start there. So we're going to start with the method within this class. We're going to return a double, and we're going to call it Fahrenheit to Celsius. Now we're going to take one input as a parameter. We could call it Fahrenheit or just F, I guess. F for Fahrenheit. Hopefully that makes sense. Hopefully I didn't lose either. Alright, so now we're going to have double conversion. So we're going to have a place to store the value. Is equal to 0. Let's just initialize it to 0. Here we're going to go ahead and do conversion is equal to F minus 32. And then we're going to times that by 5 and divide everything by 9. And then all we have to do is do the return value of F. Oh, sorry, conversion. We don't want to return F because then we'll just return back to Fahrenheit. So this will give us the Celsius of our conversion here. I guess we could just call it C for Celsius too. Let's go ahead and do that. I like that. A little less typing, so sorry. I know you guys might get frustrated because I'm changing it, but I think it's just kind of intuitive. So double C, Celsius. Celsius is equal to the equation, right? Fahrenheit minus the 32 times 5 divided by 9. Alright. So this will be our Fahrenheit to Celsius. So in the main method, in the pre-algebra test, let's go ahead and code that real quick. So the first thing we're going to have to do is make an object of pre-algebra. So let's go ahead and do pre-algebra. Let's just call it PA for pre-algebra. Equals new pre-algebra. Oops. Okay, so now we have a new object of our class pre-algebra we just built. And now we'll go ahead and do system.out.println. And we'll go ahead and say, oh gosh, so we did Fahrenheit to Celsius, right? So Celsius, if I could type, is, and then we'll do pre-algebra dot Fahrenheit to Celsius, and let's do 212 because that's when water boils. So if we do this properly, we should get 100 in Celsius, right? That's how come the metric system's a little easier. Water boils at 100 and water freezes at 0 degrees Celsius. So awesome. So now let's go ahead and go back to the pre-algebra class and let's go ahead and build the opposite, right? What if we have Celsius and we need it to go to Fahrenheit? So public double, so we're also going to return a double. Except this one will be Celsius to Fahrenheit. Ooh, I think I misspelled that, didn't I? Fahrenheit. I'm noticing I misspelled it on the class here. So this one will take a double C, and I'm gonna have to fix that real quick, guys. So it should be, I mixed up the R and the E there. And it's good because now we're going to have a mistake in the other class, so it's going to say, what the heck, this method does not exist. And it doesn't exist because it's misspelled now, according to the Java. So let me go ahead and save it. Okay, so we still have a mistake, an error in this one because we don't have a return type yet. So this one's a little bit different. So we're going to do double F equals 0. So we'll just call it F for Fahrenheit. F is equal to, oops, wrong parentheses, C times 9, divide everything by 5, plus 32. So when I was a teacher for adult education, I used to actually make them learn how to fix this whole equation and do it backwards. But anyways, so now we'll do return F. Alright, let's go ahead and save this. Cool, no errors, that's a good sign. So now I'm going to go ahead and do system.out.println, and we'll go ahead and do let me make sure I spell it right, Fahrenheit. And I didn't put my quotations. So let me go ahead and put my quotations, is, and then plus PA, and then Celsius to Fahrenheit, and let's do 0. So if we do 0 Celsius, we should get, when water freezes, which should be 32 degrees Fahrenheit if I remember correctly. So perfect. We got the expected output, and of course if you guys need a different number, feel free to change the argument, right? Yes, you could put negative numbers in here, right? If we put the negative 212, we should get a different number. So negative 132.555555554. Alright. So now we could also do our linear equation. So let's go ahead and do that. Thing about pre-algebra is there's just so many different components to it, so I'm just going to kind of nitpick. If you guys have anything you want to see in the pre-algebra, just throw me a comment and I will be like, oh yeah, that would have probably been better to show first, or you know, whatever. So public double, let's do linear equation. So this is going to be good old y equals mx plus b, if you guys remember this. So we'll have one argument, well, one parameter, m, for slope, one parameter called x for the x coordinate, and the other double will be the y-intercept, or b. Okay, so now we're going to need somewhere to store the value, so let's go ahead and call it double y. Let's set it equal to 0, so, you know, y equals mx plus b, which we'll pretty much see here in the next line. So y equals m times x. So remember, mx, when they touch each other, it means times, plus b. And now all we have to do is do the return y. So now we have our linear equation set up. We could go ahead and do system.out.println. And we could put y is, I guess. And we'll call our pre-algebra object, and into that we'll pass the method linear equation. So you could have different slopes. If you want to have a 0.5 slope, that would be 1 rise over 2 run, because 1/2 is 0.5. Sorry, I don't mean to get so mathematical on you guys. Let's go ahead and put that this line, well, one of the coordinates was at -4, and it had a slope of, I don't know, 2. The beautiful thing is you guys could pick whichever coordinate you would like. So let's go ahead and give it a run and see if it blows up. So y is equal to 0. So let's go ahead and see if I did a tricky one here. Yep, that's right, because 1/2 of -4 would be -2, -2 plus 2, So if I want this to equal 2, I can make it a 4, watch. Quick math. So y is 2. Y is equal to 2, I guess. I don't know. Maybe that's a little bit better, but alright. So we have a Celsius conversion, a Fahrenheit conversion, and we also have the linear equation. Now I wanted to do the slope will be my next one, and then I think I'm going to do some geometry for the next video. So in order to do the slope, we're going to break it down into 2 components. So we're going to go ahead and do public double slope run. And into this we're going to go ahead... Well, actually, let's do rise first, right? It should be rise over run. Although we could call the method as we need it, but still, it just feels intuitive to do it this way. So double y2, double y1, and if you can remember the equation, it's y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So here we're going to go ahead and just initialize a variable called slope. We'll set that equal to 0. We'll go ahead and say slope is equal to y2 minus y1, and then all we have to do is return slope, and the angry curly brace should go away. Now we're going to go ahead and program our second method right away, because it seems silly to just not do the whole rise over run thing when we're going to work with it in the main class. So slope run, public double slope run, so we also want to return a double, and that'll be x2, and the other parameter we'll pass in is x1. Now since we never defined slope as a global variable, the only place that this variable exists is within this method, so we can reuse it. And we're not going to have any issues or errors. So we could say double slope is equal to 0. I guess we could just call it rise and run, but I'm not going to change it. Alright, I'm going to leave it be so you guys don't get too frustrated with me. And we'll do x2 minus x1. And we'll go ahead and return the slope. But it's good to know that if you don't have the global variable up here in the actual class, it's not going to store the same value. It'll store it in different values because it's in each method respectively. Alright, so now that we went ahead and programmed that, we're just going to go ahead and do another print statement in our main method. So system.out.println. And for this, I guess we're going to have to print to the user what numbers we're actually printing out, right? So this one, I don't think we have to do, whatchamacallit, because I want to try to print it out as a fraction. So we don't need the space. We'll go ahead and call pre-algebra.slope rise. Into that we could pass for a -1. Could really pass any value that we would desire, plus, so in order for it to look like a fraction, we're going to need a new line to go underneath our value. We'll do 3 minus signs to kind of go underneath, and then we'll do 1 \n, so the next value we do will actually print underneath this. So I'll show you guys what I mean. Now I'm going to go ahead and do the plus for the concatenation and hit enter. And I'm going to line up everything right underneath this quotation mark. So now we'll call PA slope dot run. And for this we could set a negative value of 3 and 7. I don't know. I'm just kind of throwing random numbers out there. So let's go ahead and run this and see what happens. Okay, so slope is 5, so 4 minus -1 is actually 4 plus 1, which is 5, right? And then -3 minus 7 would be -7 more, so it's like adding it in reality. So it becomes like -3 plus -7, which is -10. So 5 rise to -10 run. Those of you that can simplify really quickly, they're both divisible by 5, right? So this would actually be a -half slope. Alright, so I think we're good. I think that's all we're going to have time for now. I'm trying to think if there's anything else we could program. And I think I'm going to leave it with that. I think we'll go ahead and leave with just these 4 things. As I say, this will probably be a series, so I'll keep adding on until somebody else has a problem. And until then, we'll just build this really robust pre-algebra class that we can have references to and really go ahead and go back and build onto something, right? So I hope you guys enjoyed the video. If you get the chance, go ahead and leave me a like. Leave me a comment if there's something confusing. Leave me the code in the comments if you're having some errors. Other than that, subscribe, hit the little bell so you get notifications for videos. I'm going to be more proactive and upload more. And you guys have a blessed day. I will see you in the next video. Bye.